All right, this lesson is on remainder theorem. Remainder theorem states that any polynomial divided by some binomial will yield the quotient plus the remainder of that polynomial, where q of x is a polynomial with degree 1 less than the polynomial that we are dividing. All right, if there is no remainder, then the divisor is a factor of the original polynomial, the dividend. The quotient is the depressed equation. So we can use two methods. We can use long division or synthetic division. In long division, we're going to add any placeholders that are necessary, and then we're going to divide just like you learned how to divide in elementary school. We're going to write the remainder as either plus or minus, depending on what the sign of the remainder is, over the divisor. All right, first example, we're going to divide using long division this polynomial by m plus 1. What you want to do is ask yourself, what do I have to multiply m by to get 7m cubed? And that is 7m squared. Then we multiply 7m squared times m to get 7m cubed. 7m squared times 1 is 7m squared. We have to change the signs and then add them up, or just subtract. Once we subtract, we get 9m squared minus 7m squared is 2m squared. Bring down the next term just like you normally would using long division, and then repeat that process. What do we have to multiply m by to get 2m squared? And the answer is 2m. So that's the next term in our quotient. Then we're going to multiply the 2m by m to get 2m squared, 2m times 1 to get 2m. Again, subtract those two. Negative 5m minus 2m is negative 7m. Bring down the last term. What do we have to multiply m by to get negative 7? And that answer is negative 7. Multiply negative 7 times m to get negative 7m. Negative 7 times 1 is negative 7. Change the signs and add them up, and we get a remainder of negative 4. So we write that as minus 4 over the divisor, m plus 1. Solving that same problem using synthetic division, we would set the divisor equal to 0 to find out what our r is. Once we do that, we're going to add any placeholders, and then we're going to bring down the first coefficient, and then multiply by r, add the product to the next coefficient, and then just repeat that process until we're at the last number in the synthetic division, the last coefficient. All right, so this is the same problem. If we set the divisor equal to 0, we get m equals negative 1. So that is our r. Next, we're going to write down the coefficients of all the terms in our polynomial. All right, yeah, if there are any missing terms, you need to add a 0 as a placeholder. We have an m cubed, m squared, m to the first power, and our constant, so we don't need to add any placeholders. We're going to bring down the first coefficient, which is 7. Negative 1 times 7 is negative 7. So we add that to the next coefficient. 9 minus 7 is 2. And then multiply negative 1 times 2 to get negative 2. Add those two. Negative 5 and negative 2 is negative 7. And then multiply negative 1 times negative 7 to get 7. Add those, and you get negative 4. Now, you just need to fill in the variables with their powers. And the first term is always going to be 1 degree less than the original polynomial that we were dividing. So the original polynomial was m to the third power, so our first term in our quotient should be m to the second power. So 7m squared plus 2m minus 7 minus 4 over m plus 1. All right, next example, we're going to go ahead and solve this one using long division. Notice we had to put a placeholder in there for that linear term, for the x to the first power term. We have to multiply x by x squared to get x cubed. So when we multiply x squared times x, we get x cubed. X squared times 1 is just x squared. Change the signs and add them up. We get negative 2x squared. Bring down the next term. We have to multiply x by negative 2x to get negative 2x squared. So that's the next term in our quotient. Negative 2x times x is negative 2x squared. 2x times 1 is 2x. Change the signs and add them up. And we get 2x. Bring down that last term. What do I have to multiply x by to get 2x? And that's 2. So that's the last term in our quotient. 2 times x is 2x. 2 times 1 is 2. When we add those up, change the signs and add them up, we get a remainder of 0. That lets us know that x plus 1 is a factor of that polynomial. The quotient, x squared minus 2x plus 2, is called the depressed equation. We could then go on to factor that to find out what the remaining factors are for that original polynomial. And using synthetic division, we're going to set the divisor equal to 0. We'll get an r of 1. Bring down all the coefficients. Don't forget the placeholder. So we should have 2, negative 3, 1, and then the constant term is 0. Bring down the 2. 1 times 2 is 2. Negative 3 plus 2 is negative 1. 1 times negative 1 is negative 1. 1 plus negative 1 is 0. 1 times 0 is 0. 0 plus 0 is 0. So we have a 0 remainder. Our depressed equation is 2x squared minus x. Again, the first term, or our depressed equation, is 1 degree less than our original polynomial.